As your mother for you, she told me that you was too young. I wish, dear Lord, that I never seen your face. I'm sorry you ever was born. Irene, good night. Irene, good night. Good night, Irene, and good night, Irene. I guess you in my dream. Sometimes I live in a country. Sometimes I live in town. Sometimes I have the great notion to jump into the river and drown. Irene, good night. Irene, good night. Good night, Irene. Good night, Irene. I guess you in my dream. Stop rambling and stop gambling. Quit staying out late at night. Go home to your wife and your family. Sit down by the fireside bright. Irene, good night. Irene, good night. Good night, Irene, and good night, Irene. I guess you in my dream. Hello, sorry, God knows I do. Love her till the sea runs dry. If Irene turns her back on me, I'm gonna take morphine and die.
All right, welcome back from the small break that you got. A couple of reminders. Remember that your first reading is due tonight at midnight, and your second reading is due tomorrow at midnight. Otherwise, all the readings after this should be pretty much due on Mondays at midnight. It's kind of front-loaded, but that's because we need to get started. And for the first couple of readings, you can expect to spend about maybe 1.5 to 2 hours on each. So keep that in mind for tonight. But as you progress, it'll get less and less. And I think on average of all the 13 readings, you can expect about an average of about 45 minutes across all 13 readings. And also I got the time wrong. If you are planning on running with us at this afternoon, or we're going at 4:00 outside the Shore Center. Very few people actually show up, so it's great if you do, though, right? But if you do, make sure that you bring a sunblock because it is quite sunny out there. Picking up from where we left off last time, we were looking at formatted output. Remember that you can use printf to print any data that you want, using the placeholders %f, %d, and %c for doubles, integers, and characters respectively. And the order matters. So if you're going to print 3 different things, then the 3 placeholders that you provide correspond to 3 variables that you provide over here. And we'll see some more examples here in a second. But otherwise, you can also change the default formatting using modifiers. X dot Y and then F, for example, where X is the minimum number of columns to print, Y is the minimum number of decimals of accuracy to print. And these are the examples that we were doing last time. Let me come over here to my my environment, and let's go ahead and try to run this again. GCC demo.c. Oh, I've got a problem here, right? It's not compiling. In fact, it says error. How do I start diagnosing these things? Well, I start reading from top to bottom, right? Because just as any story begins at the top, you don't jump to the middle. If there are multiple errors, there's only one error. But if I had like 10 errors, where should I start? At the first one. because oftentimes there's one error, one actual error that leads to 10 other errors. And by fixing the first one, now you've magically fixed all the other 9, because compilers are dumb. They need very specific instructions on how to program themselves, basically. So the way that you read this is line 22. There's something wrong on line 22. So we'll focus on line 22 in my code here of the demo.c file. Then in column 23, that's what it's highlighting right here. So what did I forget on line 22, column 33? The semicolon, as it tells you. Right? Now, somebody had asked about codehelp.app, and that's something that we've used before, but we're not using it anymore because CS50 IDE now has an integrated duck debugger. I don't know why they call it duck debugger. It's a rubber duck debugger is what it should be. But you can go ahead and launch this little chat bot here, and you can ask it questions. Why is my code not compiling? Right? And it'll say, well, what's your error message? Provide more details about this. And so what I'm going to do is I'm going to cut and paste this and bring it over here and tell it, well, I got this error. Right? Looks like you're missing a semicolon at the end of that line. Try adding it and see if that resolves the issue. Okay, great. Thank you, chatbot. I'll go ahead and add that, which I did. And let's go ahead and recompile it. And great, it works. This chatbot is perfectly fine because it has been programmed and configured to never give you answers, like just straight up answers, never give you code. Whereas we do ban the use of ChatGPT, CodePilot, etc. That is cheating. Using this is not cheating, right? And remember that it's over here under the duck debugger. You can always go back to your Explorer over here by clicking up here. Right? And because I'm zoomed in, it's not looking exactly the same. If I zoom out like normal, then you see that it's a nice little duck over here. Right? So you can ask it questions. Uh-oh. There we go. Bring that back. Okay. All right, so let's go ahead and actually run this now to see what the differences are. Once again, the default behavior here is to print out 6 decimals of accuracy, no minimums whatsoever. If we only want 2 decimals of accuracy, 4 decimals of accuracy, or 10 decimals of accuracy. If I bump this up to 100, remember what happens, right? Is that actually pi? No, at some point after 16, 17 digits of accuracy, the accuracy goes away, and the rest of this is just garbage, and it's eventually zeroing out, okay? So keep that in mind. This one is printing a minimum of 10 columns, right? And 2 decimals of accuracy. There it is. 2 decimals of accuracy, but then the period and the 3, that takes me up to 4. A minimum of 10 columns will mean that there are 6 spaces padded out front. Likewise, if I minimum of 10 columns but 4 decimals of accuracy, now I'm down to 4 spaces out front. 10 decimals, 10 minimum columns, then that has no effect because you're already reaching that minimum with the number of decimals of accuracy. Okay? All right, that is a review of basic output. What about input? And you saw this yesterday in your lab, standard input. Right? So standard input is used with interactive programs. So, for example, I'll prompt you for a number. Let me come over here and give myself some more real estate there and get rid of this. It's already in the notes. So let's go ahead and create 2 variables here, an integer x. I will prompt the user to enter in an integer. Please enter an integer. Right? And then I will, let's actually go ahead and compile this right now, and not that one, but GCC. Let's go ahead and compile that and see what it looks like just as it is right now with just that prompt. Obviously, I'm not able to enter. Why? Because it's not actually reading anything. So the thing that we use is scanf, right? And we use the same placeholders as before. Since I'm entering an integer, I will be using the placeholder %d. Right? There is no end line here because I'm not printing anything. And then I provide an ampersand and the variable that you want to read into. And then let me go ahead and print it out. Printf x is equal to %d. And the line here to make it look pretty. And I'll print out x. There's an ampersand here with scanf, no ampersand with printf. Let's go ahead and run this and see how it works again. So what is it doing now? My program is still running. It's blocked. Right? It printed out, please enter an integer, and then it called this function that is blocking the input out, blocking the execution of the rest of the program. Now it's prompting me for input. When a person mashes their keyboard and enters 123, then hits enter, then the program continues on line now 16. Right? It already read it into X, prints out X as successfully as 123. Right? What does it look like if I want to read in a double, right? A floating point number? I'll use Y here. So no longer enter an integer, enter a number. You can enter in an integer 10. 10.0 is still a double. You can enter in 10.5 and it'll still work. I'll read it into Y instead, but I need to use a different placeholder here. Normally this would be F if it was printf, but it's going to be LF for scanf. Let me go ahead and show you what happens when you use the wrong one. Right? So let's go ahead and go with Y and Y there. So clear that out and compile this again. Oops, %F, sorry. That was just a warning. There we go. Still, what's wrong? Okay, it's good. It's giving me a warning even about this. Are you sure that you meant to use %F? Well, or did you mean to use %LF? I meant to use %LF, but let's see what the consequences of this are. Right? So enter an integer, 123. Please enter in a number, 10.5. You end up getting 0 out of this. Right? And the reasons are lower level hardware issues. Basically, the difference between F and LF are 32 bits and 64 bits. So what's happening is only half of it is actually getting read, and it's being interpreted as 0. Okay. So I'm going to go back here and use %LF, and now I no longer, you see that warning that I got before using F? Now I'm going to go ahead and do it correctly, and I get no warning at all here. No news is good news in Unix world. Okay. Let's run this again. And enter an integer, 123, 10.5. Yay, we read both of those now. So what happens if I just sit here and mash the keyboard? Right? Predict, what is it going to end up reading? Is that any number that you've ever heard of? Yeah, go ahead.
It's going to read 00.
00, why?
Because it doesn't recognize any number.
Yeah, it sees, here, let me write something sensible. Hello, right? Now, H. Is that any number that you've ever heard of? Nope. So what happens is it starts processing HELLO. The first H it sees, it says, okay, I must be done reading this number. Well, what have I processed so far? Nothing. What is the numerical equivalent of nothing? 0. Right? Likewise, it ends up doing it down here as well. But it skips that entire process because I entered in garbage. Right? This is interactive input. There are ways of protecting yourself against bad users that just enter in garbage, right? For example, I will enter a number, 10, TEN. Now, is that correct? No, because it's not an actual number. It is a letter. And so I'm going to get the same issue here. You can detect this, but it goes beyond what we're going to be doing because we're immediately going to get away from interactive input here because the vast majority of programs are not written for humans. Despite our consumer electronic products that give us the story otherwise, everything is written for humans. No, that's just the tip of the iceberg. That vast majority of software is written for other software because why do you write software to begin with? To automate things. And it's not much help if you're sitting in there requiring somebody to mash the keyboard for input all the time. Okay? All right, so a few takeaways here. Actually, what else? A.out. 123.5. I said to enter in an integer. You gave me a fractional number, right? A floating point number. What's it going to end up reading? 123, right? Because once it sees that period, I'm looking for an integer. I don't care about that period anymore. Well, what? So I will. X is going to be 123. What is Y going to be? Not 0 anymore. 0.5. Now what's happening here? It's processing 123. That's the integer. Well, what's still left in the input? 0.5. So when it jumps down here to scanf, weird things happen. Right? This is why unstructured input like this is not good. Right? You have to program 1,000 lines of code to handle all possible contingencies, reprompt them for good input, send an error message to the user, et cetera, et cetera. This is why websites are great, or user-facing inputs restrict you. Please enter a number, or please enter in a date. What happens? You click it, and up pops a calendar. You can't put in February 31st, 2024, because there ain't no such date, right? Instead, you are directed to, well, pick one of these dates, and that's it. Or you enter in a negative number, and it doesn't allow you to do that. It immediately it doesn't let you enter like the hyphen at all, right? You don't have that kind of structured input at the command line like this. So you have to deal with it in other ways, okay? So the takeaway on this is that the standard input is with interactive programs. You use scanf to scan the standard input, the keyboard, for user-provided input, right? Very limited, very brittle, right? In other words, it's easily broken, right? With scanf, you use the same placeholders, except for double values. You use %lf instead of %f, right? And here's another gotcha. When using scanf, always remember the ampersand. That is this symbol right here, in front of the variable. Right? Why? For now, it's magic. Right? Let's see the consequences of not doing that, though. All right? What if I come over here and I forget the % sign? Well, first of all, GDB or GCC is going to try to save me from myself, and it's going to warn me about that. It's just a warning. It's not an error. It's going to let you do whatever you want to do, at least in this regard. It's going to ask you, wait a second, you're trying to read in an integer, but did you forget the ampersand there? Right? And so when we run this, and please enter an integer, I'll be nice, 123, good input. And by the way, all of our grading will be good input. We're not going to give you TEN when you expect an integer or something like that. Right? Segmentation fault. What's going on here is that my program is trying to access memory that doesn't belong to me. Just remember, when you see a segmentation fault, at least for the first few weeks, it's likely that you missed an ampersand. And the compiler will remind you about that. There is something going on with this line that you need to fix. If I were to take and put this into the debugger, let's do it. I'm going to get an even more, let's see, where is it? Let's just ask it a question here. What does the following warning mean? And then I will cut and paste it all. The warning indicates that scanf expects a pointer, blah, blah, blah. For example, you should probably pass the address of the variable using ampersand operator. So you can use this to start making fewer mistakes, or at least explain your mistakes. Right? So once again, let me go back over here and use the ampersand. Okay. That's standard input. As you saw yesterday in your lab, there's also another way of doing input, which is non-interactive input. And again, the interactive input with scanf makes the program pause or block. I'll put that term there, block. Right, there we go. And wait for human users to enter in their inputs. However, most programs, especially programs at the command line, are not interactive. From the command line, instead, you can do non-interactive input by providing CLAs, or command line arguments. Okay? CLAs are provided when you start the program. For example, when I run a.out, I can provide hello, 10, and 3.5 as arguments. There are actually 4 arguments here. There are actually 4 arguments. The first argument is always the executable file name. In this case, it's a.out. Right? So this one ends up being the actual first argument here. Then this is the first user-provided argument, the second user-provided argument, the third user-provided argument, and of course this is going to be the first overall, second, third, and fourth, because there are actually 4. How do you tell how many command line arguments there are? So let's come back over here and remind ourselves that I said this is magic for now. Now it's no longer magic. These are the inputs to your main, which is your program, where your program starts. argc and argv. Well, argc, it's of type integer. Right? It's going to be a whole number. So what does argc stand for? Argc is the number or count of arguments. Right? So that's what the C stands for. I'll emphasize that by highlighting that in bold there. Right? It's the argument count, or number of arguments. ARG, short for argument. Right? The argv is an array of the arguments. V is for vector. Don't worry about that. Right? It's weird, right? But whatever. So how do we access these things? The first argument, that is the executable file name, is always argv sub 0. Right? This square bracket notation here. Now, when we get to arrays, this will be much clearer, but for now, don't worry about it. We will use command line arguments going forward, but don't worry about the actual problems with arrays or anything. The second argument, that is the first provided by the user, is at the next one. So it's going to be argv sub 1. Right? And then you have the rest of them. argv sub 2, argv sub 3, etc. Right? You can have as many command line arguments as you want. Generally, you only want a few of them, though. Okay? So how do we go about processing this stuff? Processing CLAs. Right? CLAs themselves are strings. More on that later in the semester. Much later, I think like week 9 or something like that. For now, just understand that they're strings. Things like hello. All right? That's a string because it's in double quotes. All right? That's not a number. If we need to convert those over to numbers, we can. Right? To convert an argument to an integer, you can use A to I. To convert an argument to a double, you can use A to F. Right? So what do these mean? The A is alphanumeric. 2 means that you are converting to a different thing. I in this case stands for integer. F in this case stands for floating point number. Okay? Let's take a look over here at this program. I'm going to take this program that prompted the user for input, and I'm going to get rid of that prompt. I'm going to get rid of that interactive read, and I'm going to keep the print there, but I'll move it down here so that I'm printing X and Y, and get rid of this stuff right there. All right. Now what I want to do is I want to take the command line arguments, the first one and the second one provided by the user, and I want to convert them. Right? So X will be argv sub 0. Well, first of all, is argv sub 0 going... I'm going to try to run it like this. A.out, 10, and 3.5, just like in the example. Where this is the first user-provided argument, this is the second user-provided argument. Is that where 10 is going to end up being? Now, remember, the first argument is A.out. So it's the first one, the integer, is actually going to be at argv sub 1. Unfortunately, the thing on the left-hand side is an integer. The thing on the right-hand side is a string. And so if I were... Oops, cancel that. If I were to compile this, I'm going to get a warning. You cannot convert from an integer to a string, a char star, which is what a string is in C. All right? So what do I need to do? I need to provide A to I. That will take the command line argument as input, parse it out to be an integer, and then places that value into the variable X. Right? Same thing for Y, except for A to what? Since it's a double? F. Argv sub 1. Of 2, excuse me. The second one. There we go. Now let's do this. So if I run this normally, 10 and 3.5, perfect. Right? It read in 10 is the first command line argument, user provided. 3.5 is the second user provided command line argument. You still have the same problems as before. What if I just mash my keyboard? 10 and some more. Right? So what's going to happen here? Predict based on what we've already seen.
Crashes.
Okay, crashes. Zeros, why? Because is T a letter that you, or a number that you've ever heard of? Nope. Is S a letter or a number that you've ever heard of? Nope. So 0 and 0. When it crashes, here's me refusing to give you input. It's expecting 2 command line arguments from the user in addition to the executable file name. What happens now is that it definitely crashes, right? It crashes because I'm not providing the proper number of inputs here. But as long as you provide the proper number of inputs and then 3.1415, something like that, then it'll work. Negatives are perfectly fine. Zeros are perfectly fine, right? You can even, I think, do scientific notation. 3.1415 e to the 10. There we go. Yep. So take it and multiply it by 10. And you can do that with strings as well and other stuff, but generally you don't use scientific notation directly. Nobody's going to be entering that as a command line argument, right? No. All right, so there is non-interactive input. Otherwise, output is exactly the same. So here's our example that we just developed, and that'll be in the notes when we post it later today. All right. Any questions so far? No? Then let's do an exercise. Exercise. Write a complete program from scratch to compute the roots of a quadratic polynomial. Right? So a quadratic polynomial looks like what? A general form is going to be ax squared plus bx plus c. Right? Looks familiar? How do I go about solving that? How do I go about finding the roots here? What's that thing called? Can we do it before? There we go. There's the quadratic equation. Right? So let's do the first version of this, since we have plenty of time. Let's do the first version of this interactively. Right? So I'm going to go ahead and close this out and create a new file here, since it's from scratch. Right? I'm going to go ahead and call this compute roots interactive.c. Right? All right, what's the very first thing I should be doing here? Okay, I'll definitely need to include stuff eventually. Yeah. Write a header, an author header. All of your basic programs are going to require at least one author header. If you were to write a 5-paragraph essay over in your English class and you didn't put your name on it, right, or the class or whatever, right, they're not going to even grade it, right, because who the hell wrote this thing, right? So the author, at a minimum, me, the date, 2024, 0904. And by the way, this is the IEEE, ISO 8601 standard. So when you write dates, start getting into the habit of using that. Today is September 4th, 2024. That's the wrong way of doing it. Well, I mean, that's very descriptive, but that's the human-centric way of doing it. What's another way of doing it? 0904 2024. That's the American way of doing it. Month, day, year. It's wrong. The European way of doing it is also wrong. Day, month, year. Right? None of those are lexicographically orderable. Right? When we write out a number, say 1,207,000, do I go 207,000 and a million and 1 million? No. I don't write those things backwards. I write the things with the highest order of magnitude first. What's the highest order of magnitude here? It's the year. Then the month, then the day. This is the proper way of writing dates. Everybody else does it wrong. Only computer scientists do it right because it's lexicographically orderable. Right? Anyway, there's the date. What else goes in your header? Description. This program reads in 3 coefficients from the user and uses the quadratic formula to compute the roots of a quadratic polynomial. And if you want to get really fancy, you can cut and paste this mathematics if you want to. Let me go ahead and do that. I'll go ahead and cut and paste this mathematics over here, and there we go. We can just use regular old math over here. If you want to get really fancy, you can go ahead and link to an article about the quadratic formula. Wikipedia. All right. I'm going to go ahead and take their article and say, see more at ahref equals that thing. Oops. There we go. Here. And this is the reason that that we like doc style documentation, because what you can do is you can run a tool that will take this and then format it, and then this becomes a linkable link, basically. In fact, in my IDE, it already is. If I hold down the command, I'm in Mac, so if I hold down the command, probably Control on Windows, I can actually click there and be taken right there. That's actually true of anything. If I want to include the math library, probably going to want to include that because I'm going to be doing a square root. If you really want to take a look at what's in that math library, you can go ahead and take a look. There's the math library, a bunch of code that's already written. Okay, I'm holding down the command key, and then it becomes linkable. Okay, what else should I include though? Always something I should always include, no matter what. stdlib. In fact, most compilers will probably do that automatically for you, even if you don't ask for it, because it's standard. It's got to know what an integer is. Right? What else should I put, since I'm going to be doing input and output? Standard input-output. Okay. What comes next? The main. Int argc char star star argv, and then a return of 0. There we go. All right. Let's do this interactively first. I'm going to prompt for input. Printf, please enter A. Right. And then I'll scan for it. Scanf. Well, what's wrong? Do I have a variable that I can put this result into yet? Nope. So what should we do before that print statement? A, B, and C probably, right? Int A, B, C. Making the choice that they're going to be integers, it's kind of limiting, right? Can you have coefficients in a quadratic polynomial there that are 0.5? 1/2? Certainly. So that's an argument to use a what instead? Double. All right, there we go. Please enter A. What's the placeholder for a double when you're using scanf? LF. And I will go ahead and enter an A. What did I forget? The magic. The ampersand. Yeah, or the and sign. Right? All right. Copy, paste, copy, paste. Don't get into that habit. It's called copy pasta. And it's called copy pasta for a reason. That if you copy, paste, change, eventually you're going to forget that you didn't, or you're going to miss something. For example, what did I not change? I want to enter in B and C. A, B. What did I forget? C. Right? So you're going to eventually copy, paste, get into that bad habit, and eventually you're going to miss something, and you're going to be searching around what the heck is going on for that one line. Not that you have to retype everything, but it's this copy paste is a bad habit to get into. Right? Copy pasta. It leads to spaghetti code that is all mashed up together that you can't read because you can't determine, is that noodle part of that noodle or not? Right, that's why it's called spaghetti code. Okay. All right, let's go ahead and compute the quadratic formulas. Guess what? We already did that. Right. Where is it? My notes. There we go. I'm going to go ahead and grab this and just copy paste it because we already wrote that code. Right. All right. Hey, I've declared some doubles up here. I've declared a double down here. That's perfectly fine. If you want to get in your time machine and go back to 1980, this is not fine, right? I don't want to go back to 1980 where it's not fine, right? I think that we could go GCC, or not, GCC compute roots, right? Sorry, with the math library. There we go. I'm going to add something else. Pedantic. Did I spell it correct? I think so. All right, I'm going to go back to 1980. Oh, no. Darn it. Okay, I lied. I was going to show you something here. Pedantic C is let's see, maybe it's std equals C89. Yeah, there we go. All right. So only in 1990 did they allow you to do something like this. 34 years ago, right? Actually, no, in 1999, maybe? Because the C90, that's 1990, forbids the mixed declarations in code. Basically, what you had to do prior to whenever they changed that is that you would have had to come up here to the top and declare x1 and x2. You could not declare variables down here. I don't like living 30, 40 years ago, right? It is okay. In fact, it's preferable that you declare variables where it makes most sense. Right? Sometimes it makes sense up here. I need all three of them. You can separate this into 3 different lines: double A, double B, double C. But why? Right? And then move this down. Well, I don't need it until down here, right? I don't need this until down here. And so I'll move them all over the place. That's way less readable than what we had before. I'm going to be creating A, B, and C and immediately reading them all in. So just leave them all up here. And in fact, don't have 3 lines of code. Why use many words when few words do, right? Just have 1 line where you've declared them all. They're all the same. Right? So writing terse, small code is better until it gets too terse, too small, and it's no longer readable. Right? That's called the Goldilocks zone. Not too hot, not too cold, just right. That is readable. Right? Arguably, X and Y are not great variable names. Yes, mathematically they're good variable names, but more descriptively, we have root 1 and root 2. Right? Once I've computed those, then I can go ahead and print them out. Printf, the roots of %f x squared plus %f x plus %f r, %f, and %f. So what do I have there? I've got 5 placeholders. That's going to be the coefficient A, coefficient B, coefficient C. So that's going to be A, B, C. And then the 2 roots, root 1 and root 2. Right there. Okay. Let's run this and see if it works. Get rid of that stuff. Remember that sometimes if you're using the math library, and in this case I am, square root, you also need what? Hyphen LM, right? Dash LM. That's going to link in the math library because GCC is not set up or configured to automatically do that for you. Once you've got that, then you can go ahead and run this. Please enter in A. Okay. 10. Please enter B. 20. C. 20. The roots of 10, 20, 10 are -1 and -1. Is that correct? Pull out your calculator and do it, or pull out a better calculator that'll do it for you. What did I do? 10x squared plus 20x plus 10 roots. Thank you, Wolfram Alpha. The roots are -1. Multiplicity 2 means that both roots are negative. There are 2 roots. Both of them are -1. Right? This is a proper test case. In fact, properly, what I should have done is I should have decided I'm going to test this program based on the inputs 10, 20, and 10. Take it over to Wolfram Alpha or your calculator or whatever. Compute the expected output, which is right here, -1. Then run your program to see if that's what you get. That's a passing test case. This is what CodePost does. We have input, we have expected output. We run your program to get the actual output. If the actual output matches the expected output, it passes. If it doesn't, you need to go back and fix it because it's wrong, right? Give me another input. In fact, let's do this correctly by looking at the input and the expected output first. Give me 3 other coefficients. No?
7.
Okay. 1, 7, and give me another one. -5. All right, -5 right there. What are its roots? Weird. Okay. They're symbolic roots. So I'm going to have to go ahead and click on those. And then I will get -765 and +653. And so you said 1, 7, and -5. 1, 7, and -5. Looks right to me. Remember, it only goes out to 6 decimal places of accuracy. Right? I'm pretty convinced that this works. What happens when somebody mashes their keyboard? Hello. What's that going to end up doing? 0. And I get a whole bunch of garbage there, right? In fact, the roots are some random number and some random number here, right? So I'm not protecting myself against bad input here. Again, that goes beyond the scope of this thing, right? Let's go ahead and change this, or at least I'll leave this one as it is, and let's go ahead and copy it. And, oh, okay. Fine. I'm going to copy compute roots over to compute roots CLAs, right? Command line arguments, right? I'm going to go ahead and get rid of this. And remember, if you sometimes these don't show up, but you can always refresh your Explorer up here. There we go. There we go. This program reads in 3 coefficients from command line arguments, not from the user, and uses the quadratic formula to compute roots of the quadratic polynomial, blah, 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 blah. How am I going to change this? I'm no longer going to prompt the user for input. Instead, I'm going to say that A is equal to A to I or F? F, because it's a floating point number, a double. Arg v sub 1, the first one. Here I will go ahead and commit this in a copy pasta. There we go. A, B, C. Just make absolutely sure that I change everything 2 and 3. Right? Now let's go ahead and compile this version instead, compute roots CLAs, right? Using the math library. Run this again. If I don't provide command line arguments, I'm going to get that same problem of a core dump, a segmentation fault. So let's provide those command line arguments. What do we say? 1, 7, and -5. Yeah, same answers as before. Right? Remember, it is 7, 6, 3, 5, and 6, 5, 3, etc., etc. Right? Exactly the same. Right? If I don't give correct input, I don't know. Right? There we go. Then I'm going to get weird numbers here. Right? Why is that? What's some other bad input that I could give this thing? That is truly numbers. I'll give it numbers. I won't give it a bunch of letters. But what is some bad input that you could have for a quadratic equation right here? Well, remember, what does it look like? B squared minus 4AC. What could happen? What could go wrong with that radical right there? Negative. In other words, B is very large. So A is small, B is large, C is small. What's going to happen with square root of a negative value? Oh, sorry. Sorry, B is small. I should go 10, 1, and 10. There we go. Not a number, not a number. Why? Because the roots are going to be complex. This program is not written towards complex roots. Okay? What else could go wrong? Look at that equation and tell me what would break it. A is 0. A is 0, what happens then? Yeah, do you have a quadratic equation anymore? No, you got a linear equation. Right? Just solve it, right? Minus C divided by B. Right? But what happens here? If I go with 0, I don't know, 10, 1. Now I get different bad values, not a number, and int, because I'm dividing by 0. Right? Again, no arguments, error, bad arguments, error, etc., etc. With our last 10 minutes here, let's have a preview of what we're going to start on Friday and take care of this stuff. Before I start looking at the command line arguments, I want to know, did you provide me the correct number of command line arguments? Right? So if argc is not 4, then we have an error. ... Right? Why is that? Because a dot out, that's the first command line argument. Then A, B, and C. So I'm expecting actually 4 command line arguments. This is going to require a conditional. If argc is not equal to 4, then we can choose to do something else. Right? Printf, error. You need to provide A, B, and C as command line arguments. Right? And I will go ahead and exit on them. Right? Normally, this program, if the command line arguments are 4, it would go down to the linear control flow and continue executing on line 26, 27, 28, etc., etc. And then ultimately, it would end the program down here. I'm going to end it early. You give me bad input, there is no way that I can recover. I'm the program right now, right? So what I'm going to do is I'm going to exit out the entire program and kill it. Right? Let's go ahead and compile this again and see what happens when I don't provide any command line arguments. I get that error message instead of weird numbers. Right? If I only provide one command line argument, same message. You provided A, but not B and C. 2 and 3. There, finally, right? I got down to the rest of the program. But not a number, not a number. Right? After I've read them in, I can make further checks. Right? If A is 0, this is not a quadratic equation. Right? How do you think I would do that? Well, if I checked for A, arg C is equal to 4, after I've converted it, if A is equal to 0, then I've got a different type of error. Right? Let me go ahead and cut and paste this and modify it. Right? Error. A cannot be 0. That is a linear equation. You know how to solve that. Right? And then we'll exit on them. There we go. So now when I compile this and I run it again and A is now 0, you cannot be 0. That is a linear equation. You know how to solve that. Right? You don't need a fancy quadratic formula to do that. Right? That gets us into conditionals. An if statement. If this thing is true, then execute this code. If it's not true, right, then does that code get executed? Nope. If this is not true, it jumps down to the end of that block and continues normal execution. We read A, B, and C. That's not true, so we continue down here to line 35 and execute the rest of it. Again, if I give this good input, 1, 2, 1, then it will execute just like before. Right? It's making these checks, but these checks are passing and saying, no, A is not 0. We do have a quadratic equation here, and they provide us the correct number of command line arguments. We'll be looking at that more fully on Friday. Otherwise, any questions? Nope, not back there. No? All right, then all this will be posted later today as well. Make sure that you're doing your reading by the end of the night for reading 1.